Welcome to Weather Extra. I'm meteorologist Jillian Grace. Thanks for joining us today. We have lots to cover on this week's show as it was another busy week of severe weather across the nation. The spring season marks the most active time of the year for tornado development across the United States, and that's exactly what has been happening since the spring has officially sprung. Now, we know that tornadoes can form at any time throughout the year, but there's a distinct seasonal peak in tornadic activity, and it begins in April. According to long-term weather records, April, May, and June are the most active months for twisters in the U.S. An average of 1,333 tornadoes were reported across the nation each year between 1991 and 2020, and 54% of those occurred between April and June, with May being the most active month across the nation. And it's been nearly a decade since the last EF5 tornado struck in the U.S., making it the longest span on record without a twister of that magnitude. Winds in an EF5 are greater than 200 miles per hour. The nation's last EF5 tornado struck Moore, Oklahoma back on May 20th in 2013, where winds got up to 210 miles per hour. In the U.S., there have only been 59 EF5 twisters since 1950 across 19 states, one of those moving through Waco about 70 years ago. And this year alone has already been very active with over 270 confirmed tornadoes. And one of those just hit over a week ago is now considered the strongest of the year so far. Over a dozen tornadoes were reported across the southeastern United States back on Friday, March 24th and Saturday the 25th, leaving behind multiple casualties and unimaginable scenes. The devastation began Friday night as a monstrous tornado ripped across Mississippi, which ended up killing more than 20 people and would go on to travel on the ground for more than 100 miles. One of the hardest hit places was Rolling Fork, a town of about 2,000 in western Mississippi. 16 of the 21 fatalities this twister caused in the state happened in Rolling Fork. Businesses, schools, and homes that all once stood were reduced to piles of bricks and wood. Power lines were torn up out of the ground, and trees that managed to survive the twister were stripped of their leaves and bark. But many trees were thrown around, some even impaling houses and cars, showing you the force of the tornado's wind. The structures that remained standing after the twister appear to have lost walls and roofs. One local National Weather Service meteorologist from Jackson, Mississippi, said this is the worst tornado damage that he has ever seen, calling it very catastrophic. The National Weather Service gave this twister a rating of an EF4 with max winds reaching 170 miles per hour. The twister would race northeast across Mississippi, traveling through rural towns, still leaving behind a path of destruction. On the other side of the state, a second tornado appeared to drop out of the same storm and rip through the town of Amory. Take a look at this footage, captured by the local high school security cameras, showing us the moment the tornado struck. Just listen at how terrifying those winds were. The storms later moved into Alabama, Georgia, and Tennessee, where more tornadoes were reported. The death of at least one person in Alabama was blamed on the storms. Debris from the twisters ended up trapping many across the Deep South, block after block of complete devastation. Throughout that severe weather outbreak a week ago, there were 21 confirmed tornadoes across the southeast, with 22 lives lost. Wet weather has been the story throughout winter and now into spring for the state of California. One of our major weather stories of the past week was that additional round of soaking rain, damaging winds, and heavy snow that fell across the Golden State. Take a look. Another strong Pacific storm system, number 14 of the season, packed a powerful punch across the state of California last week, dumping heavy rain along the Pacific coastline and lower elevated areas. But across the mountaintops, heavy snow covered everything in sight, and it created a nightmare for travelers on California roads and also kept those first responders very busy. That heavy snow also added to the state's historic snow totals they've seen this winter. Lake Tahoe has now received over 56 feet of snow, making the 2022 and 23 winter season the second snowiest on record. And on Mammoth Mountain, over 20 inches of snow fell in just 24 hours, which now brings the total snowfall of the season above 700 inches, which surpasses the all-time season snowfall record. Since December, unbelievable amounts of snow have been falling across the Sierra Nevada mountain range, leaving many residents trapped for more than a week. The National Guard was called in to rescue residents buried in their homes due to all of this snow. Across the lower elevated areas in California, that massive storm system swirled off the coast, bringing round after round of thunderstorms, which produced heavy rain and even hail at times. Nearly 3 inches of rain fell across the Bay Area last Tuesday. This is on top of the unseasonable amount of rain they've seen all year long. All of this rain that's fallen across the state increased the risk for flash flooding due to saturated soils. Numerous flash flood alerts were in place from Sacramento to Fresno down into Southern California's Los Angeles and San Diego last week. 3 people and their dog had to be rescued from the top of their vehicle in Central California. The local sheriff's department said they ignored a road closure sign and got stuck in floodwaters and had to be rescued by the department's water rescue team. Now, all of this heavy rain the state has been dealing with this year has triggered countless landslides all over the Golden State. The state has identified more than 500 landslides since the beginning of 2023. But here's a welcome sign California residents saw this past Thursday. As the storm system moved east, a rainbow was seen painted over the Los Angeles skyline. The same powerful storm system you just saw bring record rain and snow to California trekked east across the nation on Friday, bringing catastrophic destruction after a multi-state deadly tornado outbreak occurred. The severe weather threat on the last day of March covered 87 million people across more than 20 states. The outbreak unfolded across the South and Midwest Friday afternoon and evening. Tornado watches were issued for nearly 30 million Americans from here in Central Texas all the way up to Wisconsin. The Storm Prediction Center issued 2 different areas of high risk for severe storms. That's level 5 out of 5. A high risk is only issued when the SPC forecasts the most alarming severe weather events. This is the first high risk issued by the SPC since March of 2021, and is the first dual high risk since April of 2012. Unfortunately, what was forecast to be a dangerous day full of strong, long-track tornadoes and large damaging hail became reality for many towns across the nation. During the severe weather outbreak Friday, over 850 storm reports were made, 60 reported tornadoes, and even baseball-size hail. More than 14 have been killed and dozens have been injured. At one point Friday evening, there were over 20 active tornado warnings all at one time. The outbreak started around Little Rock, Arkansas, where a tornado emergency was issued as a twister ripped through. Catastrophic damage was reported across communities on the west side of the city. The preliminary rating from the National Weather Service was an EF3 with winds up to 165 miles per hour. Home after home suffered severe damage. Debris covered roadways, trucks were tossed over, and power was knocked out to hundreds of thousands. So many terrifying images of these deadly twisters were captured across the nation. Look at this video of 2 tornadoes pummeling across the state of Iowa. Scenes like you see on your screen right now were reported across numerous states. Mass destruction impacting thousands of Americans and their communities. And this is a view of some of the hail that fell on Friday. This that you see on your screen right now, the size of baseballs that fell in northern Illinois, shattering windshields and covering cars with dents. Next week on Weather Extra, we'll take a deeper dive into this tornado outbreak. All right, coming up next on Weather Extra, meteorologist Sean Bellafury joins us in studio to break down tornado statistics for us in Central Texas. We'll be right back.
Welcome back to Weather Extra. If you've lived in Central Texas for about a year's time, you probably know that April and May are traditionally our really big severe weather months. And I want to show you some of the tornado statistics for both North and Central Texas. These numbers are high because it is a big area that it's covering. But by and large, when you break the tornadoes down since 1880 by month, the 2 months that stand out are April and May. In fact, there have been 568 confirmed April tornadoes in North and Central Texas and 527 confirmed May tornadoes. Since we're getting into the heart of severe weather season, I want to just give you a brief reminder on how a tornado forms. And we're going to take actually a deep dive into tornado genesis in a couple of moments. This is the crude model. Surface winds coming in one direction and at one speed. And then aloft, we have upper level winds, which are usually stronger and usually also coming from a different direction. It's the difference between the surface and the upper level winds that creates wind shear. And whenever we talk about tornadoes and supercells, we're talking about this rotating column of air starting out horizontal kind of looks like a tornado if you tilt your head to the side a little bit, but of course you need verticality instead of a horizontal rotating column of air. Whenever we get these really strong supercell thunderstorms, the updrafts will take that rotating column of air and push it up into the atmosphere higher aloft, and eventually that horizontally rotating column of air becomes vertical. Whenever this happens, we start to see the wall cloud form, that lowering at the base of a supercell thunderstorm, and eventually a funnel could form. Of course, if the funnel reaches the ground, then it becomes a tornado. Now, North and Central Texas, of course, Central Texas too, no stranger to these really strong tornadoes, including, of course, the EF3 last year. And we had the F5 tornado that moved through in 1953 in the city of Waco. But up in Oklahoma, of course, it's a whole entire different beast. The last EF5 tornado, the highest rating on the enhanced Fujita scale, was seen on May 20th, 2013. And the Storm Prediction Center just released new research on violent tornado genesis. And I wanted to show you this because it's really cool, even if you're not a super weather geek like me. This is an animation from the research that was done on how these violent tornadoes start to form. This is extremely detailed. There's the rotating updrafts right there. We have the rear flank downdraft, which helps to increase the tornado winds. You can even take a look at what it looked like on radar as well. The storm tracks. This is very comprehensive. You can actually not only view this YouTube video, but you can also go through the individual slides and go through some of these animations. Now, the biggest thing with this tornado, an EF5 that moved its way through 10 years ago into Moore, Oklahoma, one of the things that the research found is that there was an extra oomph added to this storm because of another storm that moved in from one side of the system and then kind of ingested itself, increasing the winds on what we call the rear flank downdraft. Those winds that came out of the storm eventually got pushed back towards where the updraft was, and that helped to drop the pressures. That also helped to increase the wind speeds. This is a little complicated. It's complicated research, that is for sure. But there is a public version of the YouTube video that I just showed you on exactly what this research did and some of the fine-tuned details on it. You can go to our website to view that YouTube video. We have, of course, the animation there, the link at the bottom of the story where you can click on it and go exactly to that YouTube page. To get to it, just go to KWTX.com, click on the weather tab, and then go over to the Project Tornado tab, click that, and there you go. It's right there. Reporting in the studio, Sean Bellafiore, KWTX News 10.
Why is it so important to learn more and research about hail?
That's right. Hail is one of the 4 perils that we study here at IBHS. We study wind, wind-driven rain, hail, and wildfire. But hail in particular is a really big loss driver when it comes to severe weather. In fact, in any given year, more than 60 to 80% of the damage that we see from severe weather is actually caused by hail. Most people tend to think it's from tornadoes, but it's not. It's hailstones. We see so many hail events that damage property outside, and it really drives up loss. So IBHS spends a lot of time researching hail. We do that research both out in the field across the country and in our laboratory here in Fitchburg, South Carolina.
Tell me about y'all's group that y'all send out to study these potential record-setting hailstones that we see sometimes.
Yeah, our Hail Quick Response team is a couple of us here from the field research team, and we go out very quickly after severe weather events when we may have a record-setting hailstone on our hands. And that group brought me and one of my colleagues down to Salado, Texas back last April after a hailstorm came through because we saw a picture on social media of a hailstone that was just so big. I've actually got a print of it right here with me. We flew down the day after the storm hit to a homeowner in Salado who had found the stone, and she put it in her freezer because she thought it was interesting, and she happened to tweet about it. We saw her tweet, and we reached out to her with the help of the local National Weather Service office down there in Dallas, and we connected with her to go down and measure the hailstone. She invited us into her home so that we could document it. And many people ask, well, why fly halfway across the country from your lab in South Carolina to scan a hailstone? And it's such important data for us and for the research engineers here at IBHS to have these really good measurements of hailstones. We don't see a lot of hailstones that are quite this big. This stone here from Salado, 5.67 inches in diameter. But getting a precise measurement on something this large and this uniquely shaped is challenging. And that's what 3D scanning really helps us with, is getting those accurate measurements. And it allows us to capture the volume of hailstones. Once we have these 3D prints, it enables us to study more about the aerodynamics of hailstones, because we can replicate their exact geometry. And without 3D scanning them, they melt or sublime away, and we lose some of that time to study them. So 3D printing has really opened up more doors for us in the research side of hail to better understand hail so we can better forecast it and better understand how it impacts us. We've done a couple of these different deployments. Now, Salado wasn't quite the state record. The state record remains the Hondo, Texas hailstone that we 3D scanned the year before, back in 2021. It fell in Hondo. The other component of our field program, beyond just the 3D scanning of the records, is we go out in the field throughout the spring and we deploy instruments in front of hailstorms that can safely measure the impacts of hailstones as a hailstorm passes over our array of instruments. Then we go back afterwards and we collect our instruments, we measure the stones that are on the ground, we 3D scan some of those as well. And then we can compare it to the radar data. So we can really get that ground truth of where the hail actually fell and how big it was compared to what the radar says fell. And that's where we've been able to make these connections between our ground truth data and what the radar says. There are very few research projects that are dedicated to hail. In fact, we're the only one in the US right now that's dedicated to studying hail. There's a project up in Canada now that's also studying hail specifically. But it's not a peril that a lot of folks focus on. Most of your field campaigns are focused on tornadoes and other hazards that come with severe weather. So this data that we collect is pretty unique.
What kind of research and work are y'all doing in the lab to continue to learn about hailstones as well?
So all of our field work informs what we do back here in the laboratory. When we started our lab here and built this facility back in 2010, we wanted to replicate hail in the lab, but there wasn't enough data. That's part of why we started the field program, was to collect that fundamental data on the properties of natural hailstones. And now that we have the largest research grade data set of hailstone measurements, we're able to realistically recreate in the lab manufactured hailstones. And that allows us to do testing against like roofing products in particular. That's a big focus of ours here at IBHS, is how hail impacts roofs. So we take the data from the field, we manufacture hailstones here in the laboratory, and then we test them against roofing products so we can take a look at what impact-resistant shingles actually live up to their label as being impact-resistant.
To hear the full interview, scan the QR code on your screen. To watch on YouTube, or go to KWTX.com/degrees of science. Weather Extra returns right after the break. Welcome back to Weather Extra. Insurance companies are still working their way through the devastation Hurricane Ian left 6 months ago. It's costing their industry some of the biggest storm losses in U.S. history, and they're taking time to recoup what they can. So where's the damaged property they're still reviewing? Well, Gage Golding visits an island in Florida that's become a junkyard for sunken ships.
Out on the water, there's plenty of places to go and plenty of things to see. But after Hurricane Ian, there are also plenty of dangers lurking beneath the water.
Every day, more and more of those big dangers, I'm talking sunken boats and vessels, are being pulled from the water. When they are, they're brought here to a big lot on Pine Island. Some will sit, while others, well, they'll get chipped.
We've probably only fed maybe 30 through the chipper so far.
That's out of the more than 300 boats Tyler Marks and his team from R.J. Gorman Marine Construction have already salvaged.
At one point in time, everything behind me was for sale.
For sale? Some of these boats are destroyed, damaged beyond repair. Yet insurance companies send them to online auctions, doing anything they can to recoup some of their losses from Ian. These ones here today didn't catch the eye of bidders.
If they don't reclaim it, it goes next door to it gets fed through the terminator.
Now, that's not a nickname. It's the real deal. The boats are busted up, fed through this big, mean green machine, and spit out in tiny little pieces. All of this happening right here in St. James City.
Oh, good. Gee, that's great news. I'm being a little facetious there. Some sort of a contest or something, or...
There's no contest, but rather enough space for the work and enough space to let these boats sit, sometimes for weeks, others for months.
Why they're staged here is to allow for a safe environment for adjusters or investigators with the state.
Now, Mark and his crew handle all kinds of titled property.
So, I mean, we've had golf carts, trailers, covered trailers, 53-foot shipping containers.
They don't shred those, rather selling them off to scrap yards. And if you notice, the shredding yard looks kind of empty, right? Well, Mark says, don't be fooled. They still have hundreds of boats they're working on fishing out. Reporting in St. James City, Gage Golding, ABC 7.
This past Wednesday, the World Meteorological Organization retired the names Fiona and Ian from the rotating Atlantic hurricane name list. This comes after those powerful hurricanes caused unimaginable amounts of destruction and death last year. Fiona swept through the Caribbean and then up north to Canada, causing at least $6 billion in damage. Fiona was a Category 4 hurricane. And not long after Fiona, Ian developed and produced severe damage in both Cuba and Florida. Ian was also a Category 4 storm and was the deadliest hurricane in more than 80 years in the Sunshine State. It caused more than $100 billion in damage. With the addition of Fiona and Ian, 96 storm names have been retired, according to the WMO. Thanks for joining us for this week's Weather Extra. We're back next weekend with the latest weather and science stories. See you then. Have a great week.